Hello, and welcome to the second part of our little video series on research in Greek and Latin using the Greek and Latin Treebank resources that are available. This discussion is in aid of a workshop to be held January 4th and 5th, 2017, coincident with the annual meeting of the American Classicists, North American Classicists, the Society of Classical Studies in Toronto in that month. And this workshop is to be held at the Westin Harbour Castle Hotel in Toronto. So, last time we had gotten to the focus of our research, that is, the research being done by myself and my colleague Vanessa Gorman. And our interest is in historiography, and particularly evaluating historical fragments for their accuracy. And as we work on this issue, we've come to realize that from the computational standpoint, that is, insofar as computers might help us, it's a question, a kind of subspecies of the larger field of authorship attribution. And so we might say that our broader interest right now is authorship attribution computationally done based on syntax. Because for our purposes, syntax is the key. Now, most authorship attribution these days is done based on vocabulary. Authorship attribution is basically simply, at its most fundamental level, a matter of counting. One looks at a text A and text B and text C, for example, and identifies what one thinks might be significant features that might distinguish the authorship of a text, and one counts them. And you count them, and then you compare essentially, usually with texts of known authorship. So if you have an unidentified text, you count certain features, and then you look for corpus. In your corpus, you look for texts of known authors which have similar numbers of that feature. So authorship attribution at its most fundamental basic level is a matter of counting, insofar as I can understand it. Now, most computational studies that are out there, and there are a great many of them, it's a highly developed subfield of digital humanities, most of these studies count vocabulary of some kind. They count features of words, either the occurrence of this individual word or that individual word, or even some studies find it's salubrious, it's valuable to count the letters in a word. Now, as I pointed out, my colleague and I feel this is inappropriate because we're looking at passages that have been quoted for their content. So it seems to us that we have to find a way to control for similar content. It's not interesting to us that passages that are about the same subject have similar words. We don't think that says much about their authorship. On the other hand, if passages about similar subject matter have similar syntax, that might well say something about their authorship that is interesting for readers to know. So, we want to count something. We're doing authorship attribution through syntax because we don't think vocabulary is the way to go. So what do we count? What do we count? Well, let's look at a visual representation of the structure of a sentence using one of the standard conventions of tree banking, using a tree graph. And this sentence, you'll remember from the last video, metadetauta, after these things, hystron, hemenas, polaisu. Of course, that's not the right word order, but that's how it's structured here. Not many days later, from Athens, came Thumokares, having a few ships. Now, what do we count here? It's a nice representation of the structure, which is why we lay it out this way, but it isn't obvious how to count, how to make a count of this. But perhaps that's just a mere contingency of the way the data is displayed. So let's look at the underlying code, XML code, beneath this visualization. And we see, as you'll be reminded, that there is a sequence of bits of data which could be certainly counted. We have the word ID for each individual word in the sentence. We have where it occurs in the sentence. It's linear order. We have the form of the word as it occurs in the sentence. We have the lemma of the word, which is clearer here. The form in the sentence is tauta, the lemma is hutos, and so on. We have the post-tag information, which is part of speech information and other morphological stuff. Tauta is a P for pronoun, P for plural, N for neuter, A for accusative. We have relationship information. Aux Y means a sentence adverbial. De in this sentence is taken to be adverbial of the sentence level, meaning I'm still talking here. The narration continues, something like that. We have some metadata, which is not, of course, relevant. And then we have the head characteristic, the head attribute. And this gives us the linear position of the word, which is the parent of the word in question. So, in other words, here, tauta has as its head word 1, and that means it is dependent on word 1, which is meta. So meta tauta, after these things, a prepositional phrase. All right, so clearly we have a good number of items that we could count and could form the basis of analysis, an attribution study, but they wouldn't be very satisfactory to Vanessa and me for a certain reason. I'll explain. We could, for example, count the number, relative frequency of, say, aux P, or the relative frequency of the subject or objects or predicates, and just compare them. So one text has many more subjects and another text has many more objects, for example. This might be of some relevance, that we might get some value from this with respect to authorship attribution, but this isn't our first impulse, because what can you say really about if somebody tells you that a certain author uses a subject much more often than an object? Can you really say from that that you have a feeling for the author's syntax in any serious way? And what we're interested in is the structure of an author. We think the syntactic structure, the way the words fit together, is the important thing for authorship attribution. That's our kind of hypothesis based on just impressions that we get reading these various authors and their fragments. So what we're looking for is syntactic patterns, and how to identify syntactic patterns that may characterize a given author. And so we don't want to just count the relative frequency of, say, adverbials in a text. even though that might be of some value. But how do we count syntactic structure? How do we find something with respect to syntactic structure that can count? That's the question that we have been working on, and that's what we're discussing. Our approach to that is what we're presenting. Now let's go back to the visual representation of the structure, and we see that this kind of graph is a really nice way. It makes structures clear. It tells us something instantly about the structure of a sentence. Is it complex? Is it simple? Is it flat? Is it deep? All kinds of terms used by people who look at graphs to characterize those graphs. So the shape of the graphical representation of a syntax structure is obviously well reflective of its syntactic structure underlying it. So theoretically, we could count the shapes of various graphs, or the various elements of a graph. We could divide this graph into subsections, and we could somehow describe the shape, and we could count how many of an author's syntactic units, whatever, how many of those shapes turned up in a particular author's work, in a particular text. This would probably reflect reasonably well about and reasonably accurately, it seems, the structural characteristics of an author's work, of an author's style, if we can speak of style. But there are problems. Computationally, it seems quite difficult to handle. Teaching a computer to do the kind of division, recognize the kind of subsections of a graph, define them, characterize them, measure them, count them. This is difficult and takes us into the deep waters of graph theory, which is a subfield of mathematics and has its own complexities that we don't want to really approach. So even though I think that this is a valuable way to think about sentences, and in the future will produce more information about syntactic structure, I don't think we can ourselves base our study on the shape of the graph produced. Instead, we have to return to the underlying XML. What part of this underlying XML represents most closely the syntactic structure? Well, of course, it is the head element. The head element tells us which word the element in question, the word in question, is dependent on. So here, as I said, word 3 is dependent on word 1, which is dependent on word 8. Word 2 is dependent on word 8. And word 8, we won't be surprised to see, if we add it in here, is the predicate of the sentence, the main verb, which is itself has a head of 0, which means it's dependent on nothing. It is the root of the sentence. When the head equals 0, you're in the presence of the sentence root. All right, so we're getting at something connected with the sentence structure here, the syntactic structure, but how to use this kind of information. Clearly, it's not directly reflective of the subject of the structure of the sentence, that word 3 is dependent on word 1, or that word 1 is dependent on word 8. These kind of there's no particular significance, I doubt, for an author's style about the thing you find at word 8 in a sentence. So we don't want to simply search through the database and find out how many times in a given text word 8 is the root of the sentence. That might reveal something, but intuitively it doesn't seem very interesting as a question. What can we do, however? We can use these information provided by head to give us something that does reflect the syntactic structure more directly, from which we can construct something that will allow us to approach this kind of thing. And that is, we get a path from this. We get a path from each leaf of the tree. Every word in a syntax tree of this kind of dependency tree is called a leaf because it every word that does not have a word dependent on it is called a leaf, like Mary and little. Every word that is terminal at the bottom end of a tree is called a leaf, and of course at the other end you have generally a single root, which is the word that hangs graphically directly from this representation root here. So here's a toy example. Mary had a little lamb, and we see that it's been treed, and Mary is the subject, lamb is the object, had is the predicate, and the root. Determiner, an attribute, little, and so on. Now, we know that for each word in the sentence, there will be a one and only one path going from the item to the root of the sentence. And this path, we postulate, will reflect in some meaningful way the sentence structure. So, we have created what we call syntax words by following this path and writing down whatever we come across there. So we start at Mary, which is the subject. We go up to had, which is the predicate, and as a result we have a construction, and then we go to the root, subject, predicate, root. Or we could start here and we have for a structure, determiner, object, predicate, root. And these constructions, which we see over on the right hand side for this toy sentence, we call syntax words, swords sometimes, for short. Well, so what you have is the idea that every word in the sentence represents a path from itself to the root, and there's only one such of these. geodesics they're called, which is the shortest path from one node in a graph to another, and that if we follow these paths going from head to head to head in our XML, we can put together meaningful units of structure that we can then subject to the techniques of authorship attribution. Now, fortunately, XML code can be relatively easily manipulated by those who know how to code. For some of us, it's much more difficult, but some are able to do it with relative ease. And in any case, it's not impossible for those without much training, like myself, to generate from the Treebank XML code other XML code which has here syntax words. So here is the first 9 words of the Xenophon sentence, with each of the syntax words represented here, you see. Now let's look a little closer. It's a little fussy, so we'll eliminate a few. Notice that this is word number 1, meta, and it says it's an aux p, that is, it's a here's the sword, the aux p, which is a preposition which depends on a predicate, which itself is the root of the sentence. Or the second word is aux y, which is a sentence adverbial, which depends upon the predicate, the root of the sentence. Or here, tauta is the adverbial after these things, sets the time, which is dependent on the preposition, which is dependent on the predicate root of the sentence. So, running this analysis and running these transformations, we can take our corpus of annotated Greek, that is syntactically annotated Greek, which is the Treebank, and we generate a corpus of equal size, having for each word in the corpus a syntax word. Each word in the corpus is now represented by a syntax word, which we posit, we hypothesize, encapsulates in some useful way the structure of the sentence, and therefore the distribution of the relative frequency of these items will help us with the authorship attribution question significantly, without any reference to vocabulary, without any reference to the particular words that are used in the situation. All right, well, thanks for listening. That's we've gone on long enough. And that's the end of the second part. In the third part of this series, we'll explain what you do when you have this data. How do you see? How do you test it to see if it's of any use at all, if you're on the right track, if this stuff will be at all valuable for telling one author from another.